Good afternoon, everyone. So my name is Evadne, and today I'm here to talk about leveraging ETS in your application effectively. So a little bit outline of this talk. First, I will give you some background of how ETS came to be. Then I'll talk about how it is used from the public API, and spend some time on the match specifications bit of ETS, which in my opinion is the best bit. Then I'll talk about some use cases of ETS, so you know not only how to use ETS, but also how not to use ETS and how to not use ETS. Lastly, I'll talk about certain adoption topics. So for me, I am a programmer. I write Elixir code most of the time. And when I'm not writing Elixir code, I'm fixing Elixir code. So here's my contact information, which will be available also in the slide release later. So a little bit of background on ETS. First, in order to understand how ETS came to be, there is actually a paper from Joe, and in this particular paper, A History of Erlang, he did mention that ETS was created in order to fulfill a certain business requirement. In this particular case, it's because there's a requirement to build a relational database to manage a lot of data. So Minutia was required, and in order to implement it in Erlang, an Erlang module was required. So that was why ETS was created, according to Joe. So basically, you can think of ETS as some kind of escape hatch from the functional world, because certain things that can be done very easily in Java or in some other languages where you can mutate variables cannot really be done properly or quickly or easily in Erlang or other functional languages, which do not allow you to mutate values. Essentially, you can think of ETS as some kind of escape hatch. Obviously, there are some interesting functional data structures that you can probably use in your application to avoid using ETS, which you can refer to in the paper, purely functional data structures. All right, so ETS per se. The conceptual model of ETS is that each ETS table holds a bunch of objects. Each object is represented as tuples. Tuples offer you O1 access to any element within it, unlike maps. So tables are held by processes, but this is more or less a loose definition. Processes create tables, and when the tables are created by the process, it's owned by the process. It will always be there until the process dies or until the process chooses to give away the table to another process. So this is basically how you can think about it conceptually. Process holds ETS table. Table holds objects, and table can be given away. Or if a process dies and there's an error, then table will be given to the error. So you can do it this way, yeah? ETS new table name, and then you will have to specify what sort of table it is, like is it a set or a set, back, duplicate back. You have to specify that. And in addition, you can specify whether it's public, private, or protected, and also read, write concurrency and other stuff. You can always specify these things in the options. When you insert objects, you can either insert one tuple or you can insert a list of tuples. And once you've done that, you can do key-based lookup or matches or selects. So as I said before, there are 4 different table types in ETS. So set order, set back, and duplicate back. The main differences are whether you can have one or multiple objects per key, whether duplicates are allowed, etc. And as I said, there are public tables, protected tables, and private tables, depending on the access requirements. However, in your application, usually when you want to use ETS, it's because of a performance bottleneck. When that's the case, you really don't want to have protected or private tables, because in that case, only one process can access it anyway, so you won't have any kind of improvement. So the key functions are here, which you can refer to in the official Erlang documentation. I do want to call out, though, that especially when writing something as complicated as match specifications, sometimes it might be easier for you to write a function that does the same thing, and then use the fun2ms function in ETS to convert it to a match specification, and then use that in your code, which is simpler usually. As I said, the core of ETS really is on matching. So you got a bunch of objects. They're tuples. They may have like the same number of elements. They may not. You want to form match specifications so you know what are the objects that we're looking for, what are the additional conditions, and also for the objects that we have found, what will the return value be? For example, you can look for a bunch of tuples, but you probably don't want all that information returned to you. You just want a specific thing or a specific combination of things. So you can use the match body in this case to specify how exactly you want the shape of the return data to be. Yeah, so here's an example of how you can do match object. Match object is the simplest API in ETS that allows you to grab something. In this case, I've created a new table called table name, And then I got a reference, so I then inserted two objects, in this case, two tuples. Each tuple has arity 2, so then I can say, okay, I'll match an object, which is a tuple, and then I do two atoms, $1 and $2. This means that they can be the same, they don't need to be the same. So in this case, I'll get both. But in the first line, you can see I'm matching anything that's in the tuple. That first $1 means that anything. And the second element must be 2. In this case, I will only get one of them returned to me because only one of them will match. So obviously, you can also do it in a more complicated manner. So you can do ETS match, which is roughly the same thing. You can also do select. So select is where match specifications come into view, because earlier on you were only looking at match patterns. But in this case, you can see now we have still two objects. Each object is a 4-element tuple, and we got a match specification, which again is a 3-arity tuple. The first bit is another tuple, which means that I wish to match any tuple that has 4 elements in it. The first one must be an atom that's A, and then 3 other things. The second element in this match specification, the match condition, is an empty array. It means that I don't wish to have any guard conditions. Just give me everything you've got. But then you can see that in the third element in this tuple actually is a nested list. So basically, it means that for each match, return to me a list of 2 items. The first item comes from the second item in the matched object, and the second thing comes from the 4th item in the matched object. So it's kind of a complicated thing to look at. Yeah. So that's why, as I said before, you really want to use a function to match specification helper that allows you to understand what's going on, because as you can see, you can always write a function, even in Elixir, write an Elixir function that matches against a 4-item tuple, and add a when guard condition, for example, when x is greater than 5, and then return a particular thing. And the function to match specification helper will give you a match specification that matches exactly what you wanted, and you can just copy and paste this and put it in your application, which is probably simpler than staring at the thing and debugging it. Right. So this is when it gets interesting, and I will talk about use cases. Well, why exactly do you want to use ads? Maybe you got an Erlang application, but you use all the CPU because your application is not fast enough because you're doing complicated work. This is a valid use case for considering upgrading to ETS, for example. Or maybe your application has an agent, and you got a lot of things that want to know what's going on. So these other processes will always have to send messages to the agent. But well, the agent is a single process. It has a single mailbox. It has basically a single thread, if you would say so. So in this case, you will have a concurrency bottleneck. And in this scenario, you will want to use the escape hatch provided to you by ads in order to avoid concurrency bottlenecks. Yeah? So in general, this is a problem that requires a lot of consideration, and isn't something that you can always answer very quickly. There is a very good book, Designing Data-Intensive Applications, which you should really read if you haven't, but I trust that you have heard of it already. And it gives you some mental frameworks that you can use when you want to consider these kinds of problems. Right, I will now show you a little demonstration, particularly regarding agents and ads. So perhaps this will illustrate the point a little bit clearer. So just wanted to see if everybody can read this terminal. Yeah, okay, very well. So first of all, I've built a scenario based on agents. And in this particular scenario, I've got 5 tasks. These 5 tasks are, first, I will bulk load n number of items. Each item is a single element tuple that contains only 1 integer. And then I will load them into an agent concurrently. Then I will load them sequentially. Then I will read them from the agent randomly. And then I will update them sequentially. And for each update, I will increment the integer by 1. So this is working against a single agent. And it appears that it has choke when I've got 16,000 items. Well, I guess there's no need to continue then. So I'll quit this, and then let's show another one. And in this case, I will base it on ETS. In this case, I've got a few more tasks, but the idea is roughly the same. I got an ETS table, which is a set, not an ordered set, which is important. Not an ordered set in this case, it's just a set. First, bulk load in one go, which means that I use a single process to load the whole thing in one go. And then I throw it away, make another table using the same configuration, but now I load concurrently. And I read from them sequentially, then read from them in a random order, then update the number, update each row by 1 sequentially, and then update using another way in ETS, which allows you to only touch one element, also sequentially, and then use a very expensive way to first find the whole thing, and then change the value, and then put it back in. So in case of ETS, as you can see, the scalability characteristics is entirely different. And now we're reaching 2 to the, I believe, the 19th power. Yeah, so 500,000. And it looks okay, but obviously, hopefully your data is smaller than this or less complicated. Basically, the fewer keys you need to carry, the better. And the actual size of a tuple, that's really a different story. Anyway, it does demonstrate that when you're trying to find bottlenecks and trying to decide which solution to adopt to avoid the next bottleneck coming to you so quickly, you can try and consider using ETS. Yep. So just a quick recap: agents are single-threaded. When you update a value held by an agent, the only thing you can do is to write a function that will update the value and pass a function to the agent API. The agent API will run it. So you can't have any kind of concurrency when you're dealing with an agent. And for ETS, you can have some concurrency, which may basically get you out of the problem that you have. So another way to look at it is by arranging different kinds of solutions on something I call a complexity gradient. So from left to right, from simple to complicated, from one node to multiple nodes. First of all, you have hard-coded environment. Like if your application has a name can change, but doesn't change per deployment, then you can hard-code it if you want to. Or you can put something in the agent or agent server, or you can put it in ETS even. Or if you want to scale up, you can go to something like Miniature or a managed database. It really depends on the level of performance and resilience and complexity that you require. So with that in mind, I will now share with you four prominent use cases of ETS that I think are probably interesting. Well, the first one is that you can use ETS to share something called persistent shared state, which I can call presets. Second one is you can use ETS to track something that's ephemeral, but also share state, called cache data. You can use ETS also to facilitate intra-process communication, acting as a message buffer. Or you can then still use ETS for something that's even better, concurrency control, by using ETS to count things. I will explain now. The first case, using presets. Well, if you have a lot of data, which doesn't change so frequently, or it doesn't need to be fully consistent, but it takes quite a long time to pull it from the database, then you might want to grab it and put it in a static file and eliminate the database query by using ETS to back it up. So one of the examples here is a time zone data library. In this case, it's not much of a database access problem, but more or less a canonical data source availability problem, because you don't necessarily want to query an internet endpoint right away when your application starts up, but you still want to have time zone information. So the TZ data library, in order to make time zone information available to your application, basically does it with ETS. The library contains a bunch of files that contain a version of the information. And when the library starts up, it loads the content of the files into ETS tables. And then the content in ETS tables can then be used by your application through a publicly available API. Yeah, so this is one of the most relevant example I can think of, because if you use something like Timex, you will have TZ data running in your application. When you run your application, sometimes you will see time zone database version is 2019A, now upgrading to 2019B, for example. So that's at work. The second thing is more or less a solution to a well-known business problem, the same situation, where you got a scaling problem. So in this case, as described by Colin Steele in Against the Grain, which is actually a blog post. They describe exactly the same scenario, but in great detail. Basically, they've got shared state held in a separate service. And due to the setup, it takes so long to grab the state. So anything like, for example, showing me how what hotels have rooms for this particular date takes so long. Yeah. Basically, they had something similar to this, where there's a central database. The business using the back office application puts data into the database directly. The front-end application pulls everything from the database, and the users grab it through the front-end application. In this case, you've got coupling on both ends, and so you can think of this as the epicenter of despair, really, especially when your database starts being wobbly. So with a preset model, you can do it like this. So basically, replace the database, move the database to one side. You still have to have it because you have to keep your truth somewhere. But the center stage becomes a sausage factory, which has vastly different runtime requirements. The sausage factory can make a bunch of static files, and then you bundle them somehow in your application. Then what happens? Well, scaling reads of digested static files is a much simpler problem. So now you can scale much easier by, eliminating this kind of coupling, and possibly your users will be happier. Yeah. So I have to also call out that whenever you want to hit a certain database service, it takes on a very good connection, possibly 1 millisecond. 1 millisecond is 1,000 nanoseconds. No, actually 1 million nanoseconds, I believe. My math is off. Basically a lot. So you just need to be aware that there's quite a bit of latency involved whenever you need to hit shared state services. And just be wary of that. All right. So the second use case is simpler. It's called storing cache state. In this case, well, you can still reconstruct the state if you want to, but you don't necessarily want to do it all the time because it takes so long to reconstruct the state. So you want a cache layer. So to this end, I have two examples for you. The first one is called the cache tab library from process 1. So the library has an interesting setup in that it doesn't just use one ETS table. It uses as many ETS tables as you have number of schedulers. So it also uses something internally called consistent hashing. It's an algorithm that allows you to consistently tell which partition or which shard a particular key needs to go into. So it knows which ETS table to put the value into when caching. And well, it's a pretty interesting library, and I do recommend checking it. This is one way of implementing ETS for caching purposes. The second way is another library called CXY cache in Epoxy, which is basically the short name for Erlang patterns of concurrency. Well, in this case, they implemented something a little bit differently in that they don't use shared tables anymore. Instead, they use two tables, one for an old generation and one for a new generation. The reason is that in ETS, deleting single entries is sometimes very expensive, but throwing away the whole table is cheaper. So using that in combination with the idea of generational caching, it allows very cheap and very efficient evictions or expiration of old and stale objects. Right. The third use case is facilitating intra-process communication. As I said before, usually if you have a single process coordinating communication, you will have a bottleneck. So you want to avoid a bottleneck. Essentially, what you want to have is some kind of message buffer. So again, in the same library, you have something called ETS buffer. ETS buffer basically allows you to have one of three kinds of message queues: LIFO, FIFO, and also a ring buffer. So it uses order set, the order set type in ETS to allow consistent ordering of messages. You can put messages into a buffer this way. So it looks like this, basically. So just imagine at the base level, if you don't have ETS, but instead you have a single process, then you will have the same problem of bottlenecks. But since you're using ETS, the problem is mitigated to a certain level. Right. So the first one, this is my favorite. This is my favorite use case. It's called concurrency control. Basically, have you ever had a problem where in your system everything starts, by spawning tasks, but sometimes you know that a certain kind of task can only be spawned so many times. You can't have more than X number of certain things going on at one time. Otherwise, the system goes down because it uses some expensive resources. So in this case, what you really want is some kind of counter. You want to count for this particular task type, how many tasks are currently running. So you don't risk spawning more than you need to or more than you can afford to on each node. And to this end, you can use adds to count stuff because, well, put an integer in the tuple and then tell adds to count it for you. You can tell adds, hey, increment this by 1 or increment this by 2, or decrease it by 1, decrease it by 2, etc. You can use it directly that way. But obviously, with the latest release of OTP 21.2, now you have an even better solution for counting stuff called atomics. So I think it would be a good time to demonstrate to you the differences between counting in adds and counting in atomics. Right. So I got a bunch of scenarios. In this case, I got a single counter. So I got a single counting adds by using a tuple that contains only one integer. And then I made also an atomic thing that has one arity, which means that it has only one thing in it. And sequentially, concurrently update, etc. And also get after update. So it appears that when I've gotten to 500,000 items, these are separately allocated things. So in case of atomics, I'm actually allocating like scatter around like millions of atomics at the moment. So they're not together. You can see the performance characteristics are basically similar. Yeah, between adds and atomics, really not much of a difference here. Yeah, but obviously, if you want to count stuff, you don't want to just count one kind of stuff. You want to count many kinds of stuff, don't you? So this is when things get interesting, I think. Yep. So in this situation, I got a different layout. The layout for adds tables is the same, but I have changed it from many allocations to fewer, larger allocations. So in this case, I got in the first iteration, I got 1,024 arity atomic. It's in one chunk, and so on. So you can see some kind of quite a dramatic difference between adds and atomics when you use atomics, I believe, in the right way. But you have to keep in mind, though, that the timings that you're seeing here may be affected by presence or absence of memory barriers in operation. So that's why here I've got get and get again, and get and get again. So look. So when you get here, you can see that getting the values from atomics first time takes longer than the second time. So obviously some kind of memory barrier at work here. But just increasing stuff and not getting the value back is a different story. Yeah, the fan's on now. All right. So now I think we can get to the most interesting part of the talk, adopting adds in your application. Well, this is a cookie cutter layout, and you can basically change it to something else. But I would say first you get a top-level supervisor. For each table you're holding in the separate gen server, or you can hold it all in one gen server, whatever you choose to do. And once the tables are set up, you can now use the public API to access them. So don't use protected if you don't have to, and don't use private if you don't have to. Try public. Generate a secret name if you want to. And when the app starts up, you can probably create something called an importer, and the importer will import the preset data into the application to prepare the tables for use. Because, at the end of the day, you're not just writing applications using adds directly. Like, for example, you probably are already using Phoenix. You're already using Ecto SQL. So when you think about it, in the world of Erlang, the objects are tuples. But in the world of Elixir, in Phoenix in particular, the world is built upon maps and specifically Ecto structures. So if you were to find a solution that works for presets, but not just getting a list of stuff and maybe filtering, querying, and so on, then you will want a way to control ads through Ecto. And through that, I have a demonstration for you, which is possibly one way you can do it. Basically, the concept of it is that in Ecto, everything works based on a repository. When you create a repository module, it actually is a very thin wrapper around a reference to a particular adapter. And the adapter module is really what's doing the heavy lifting. So if you were to use ads with Ecto, then what you need to do is you need to write an adapter for ads that works with Ecto. So to that end, I have ported this thing to ads on top of ads to Ecto, and I think I will want to show it to you, see if it still works. Right. So this is the north wind scenario. Yeah. There's nothing here. Okay. It's missing a particular key value. Yeah, I was fixing some string stuff earlier on. Maybe it has broken something else. Yeah, okay, deletion is not working. I'll just comment out deletion for now. Okay, so basically deletion doesn't work now, but the rest works. So I'll show you a quick example. So once you've modeled your data, in this case an employee model, you can write your model in the normal way. So how you wish to author your Ecto schemas. Like in this case, I've got an employee model. Employee ID reports to integer, first name, last name, title of currency, birthday, holiday, notes, territory IDs. You can use arrays of other types in Ecto like you're used to. You can do embed schemas like you're used to. You can do belongs to manager, has many reports. So associations as you're used to. Build your change set. So cast your fields and cast your embeds. Just be careful. You can't use cast for both. You have to use a special cast embed for embeds. Once you've done that, then you prepare your data. In this case, I've got employees.json, and this is a list of a bunch of objects. So each object represents one employee. I'll fold it up for you. So in this particular employee, you've got an address, which is an embed. You got territory IDs, which is an array. You got a bunch of other stuff. So what I've done earlier on is at first I have created the importer module. Well, performs against two models. For each model, load birth orientations, loading from file basically, and then decode with JSON, build the change sets, which is important, and then insert the change sets into repo 1 by 1. Do some transformations and fix some underscore issues, in this case IDs, because the original file has IDs in one word and it doesn't really underscore correctly. Do some transformations to fix all the keys, build the change sets by using the well-known change set function. And the importer runs at startup if you want to, or manually if you want to do it that way. Then you get your data. So hopefully this time. Okay, I've got a model here. I got a repo here. So you can do model employee or model employee repo O, and it will return all the employees. And this is basically held in ads and so on. And then you can do whatever you want, like query the reports and so on. So how does the adapter work? Again, So when you implement an Ecto adapter, there are certain things you need to do. First, you have to ensure that the behaviors you want are implemented. In this case, I'm implementing 3 behaviors: adapter, schema, and queryable. You have to have it before compile, I believe. Ensure all started. This is just boilerplate, so initialize it. And at this point, grab the child spec from supervisor. In the supervisor, you've got the registry for table servers, got dynamic supervisor for holding the actual table servers, and you get a task supervisor because you don't want to be sharing that with your application, do you? So you got three kids here. And then you have no adapter specific metadata information, which you could derive from config, which will be pulled from the repo config by Ecto for you. There's no transactions and no checkout. You define the loaders and dumpers. So if you've got binary or embed IDs, you use UID, otherwise you use a normal type. This is to support GUIDs. If you want to use GUIDs in your IDs, automatically generated. And then I skip insert all for now, because I can just use insert. So again, I would strongly suggest that if you've got table servers, don't make it so all the interaction goes through the table servers. What you're seeing here is a bad example where the inserts are actually being done by the table server, but you really shouldn't do it. You should have your adapter do it directly, because otherwise you'll have the same problem with the bottlenecks. So you want to do it directly, adapter against ads, not the other way around. So you do inserts this way. Updates are more interesting in that, well, you can grab the field names from the schema. So in this case, I've reordered the key to the first element in the tuple. This is so if in the future you want to use order sets in ads, and order set will order the objects. And when ads orders the objects in order set, well, first it will compare the first element. So you want to maybe move the key to the first element, or you can use a different kind of ordering scheme. Basically, whatever you want to use as an ordering field will need to be at the first. So generate the update and have the gen server do it. So delete, have the gen server do it. So yeah, this is the bad way to do it. I'll show you the proper way to do it now. So this is where it gets interesting, where you got the match conditions. As I said before, when you interact with ads, when you want to get data out from ads, you have to specify what you want, how you want it, and also offload some additional filtering to ads if possible. Obviously, you can just tell ads to get you everything and filter in memory, but that totally defeats the purpose of ads. So instead, you want to form a proper match specification. When Ecto runs a query, it uses 2 phases. First phase is called preparation, where Ecto SQL, for example, uses the opportunity to convert the incoming query structure to SQL statements. And the second phase is execution. Unfortunately, due to how Ecto is designed at the moment, the first phase, what you get from the first phase will not contain the actual values that are used, or the values that will be bound to the statements. For example, in Ecto, you may say, select everything from employees where ID equal 5. Yeah? In Ecto, in the first phase, Ecto will ask you to prepare a statement which selects everything from employees where ID is a bound value, but you don't know which value it is. And later on, it will call execute, and then pass it the same to you. And then the design wants you to hydrate the query by then. But when you're using ads, really, there's really not much point in doing that. So at the moment, we're just not caching any of that, doing it all in execute. So as you can see, my prepare call is basically passing it through, no cache query, and doing all my building of the match specifications directly in the execute part. Okay, so I got a few examples here. So first, build match conditions. When Ecto wants you to build match conditions, it will give you a bunch of clauses. So if you were to do it specifically, so only match against clauses that that are listed that have exactly one clause, you can do it this way. But obviously, it wouldn't work for a more generic setting. So yeah, that's basically it. But I will print it out for you. So I've got the clause here. Okay. think it has been cached already, hasn't it? Okay, run import again. Yeah, it's not being printed because I actually don't have any match conditions. Yeah, I just forgot. Import Ecto query employee where x. Hopefully it works. No. Yeah, it works. All right, so in this case, Ecto gives you a Boolean expression. Expression tree looks like this. Yeah. If you were to zoom in, it's basically saying that there's an equivalence test going on, and it's between the employee ID field and this particular value. So the thing is, this value may be provided to you at this time, or it may not, if you're doing it earlier. So basically, the job to be done here is to translate an expression tree captured in a Boolean expression to a series of match conditions that can be understood by ets. Really, that's all what you need to do. So I will do it this way. I run it again. So this is what Ecto gives you, yeah? And this is what you give ets. So you give ets something equal, the first thing in the tuple, and the value is 5. Yeah, this is where you hydrate it, basically, if you have a way to return a generator in the prepared state. All right, that's the match condition. And I'll remove that. And instead, I'll do match body, match specification. I will print the match specification for you. And do it again. So, somebody's going to smite me for this. Yeah, but this is the match specification. that works for everything. And this is not very good. Yeah, you have to keep in mind. In match specifications, if you read the Erlang document, for ets, and you find the paragraphs that have been repeated. You will find something repeated all the time, which is match specification heads should contain the key. If it contains the key, it will be fast. If it doesn't contain the key, it will be very slow. So this is a slow version. But basically, since Erlang tuples can contain many items which we have previously tested, you can put 1 million items in a tuple with no problem. You could certainly give every single field its own atom. So yeah, this thing, yeah. So yeah, so match specification is here. So head, condition, body, ms. So this is the head, 11 items in a tuple. And the body contains basically the same thing. This is return value. So you need to just pay some attention to what Ecto wants from your adapter. Usually it wants your adapter to return a list of lists. The outer list contains the elements, and the inner list contains, for each element, the field that Ecto wants from you. So that's why you're returning a list of lists. And the condition basically contains only one clause. All right. So let's do it this way and have some variations on the match specification. Do I have a table name? Okay, so this is a table I have generated. Basically, it's another atom which I have used module concat to create. So this is a table name. And actually, I can do something like add tab to list and pass the name in, and I will get the whole thing in a list. Well, this is for debugging purposes, obviously, because if you got a lot of data, you really don't want to run it. But anyway, this is the table name. And this is match specification. So essentially, what we're doing is add select table name match specification. Table name match specification. Yeah. I have kind of I think there's a thing here, isn't it? Yeah, it has to be in a list. So essentially what the adapter is doing is basically this on your behalf. As you can see, the method specification returns a list of lists, and the inner list contains data for one particular thing. Ecto gets it and then casts it back into the structure that you have defined earlier on, and then you can use it. All right. So obviously, another thing that would be interesting, obviously, is the string function. So X already provides you a way to first run a query, and then run a query for like five elements or 5 objects or more objects, but set a limit. And then for the rest, use something called a continuation to query it at a later time. So in X, you can do it by first set safe traversal to enable for your particular process. So you enable safe traversal, and then you can do it safely across multiple calls. And then you do the call, and then you do another call. And once you're done, you turn safe traversal off because you're done. But this is kind of tedious. So the opportunity that's provided to you by integrating with Ecto is that you have a way to write streams. Yeah. So when you write streams in Elixir, streams can be built with string resource. You have a start function, next function, and after function. First, you start function sets up the thing, sets up everything basically for you. So first, you ensure the table is there, which again is something that your actual production application should do elsewhere. You really shouldn't do it here. And then you enable say fixed table, table name true, because you're now doing enumeration, and then do the initial selection. Initial selection from X will return to you a tuple with 2 things. One is a list of things that it has found, and the other thing is continuation. Or it will return to you a single item that says end of table. No matter how, the next function will be called. So you can sort it here. If it's end of table, then halt OK, we're done. Otherwise, well, Ecto again wants to see a particular layout. In this case, it wants to see a list that contains a single tuple, which contains 2 elements: the length of objects, i.e. the count, and then the object representations. And then you can do the next select, which will spit out yet again either this or this. And the after function is always run after each iteration. So if I halt and say OK, then it will run OK. If I don't, well, then just pass it through, because the next function needs to run again to grab the objects out. So, well, when you're done, say fixed table off. So hopefully it works. Yeah. If I press the up arrow enough times, I'll obviously find it. Okay. So in this case, import the Ecto query functions, grab the order model, which is a different model. But you can really do it, with any model. Order and do a little where, so you make it more complicated, and you ask the repo to produce a string for you. Yeah, and then you can either use string run if you don't care about the content, or enum list if you want the content, enum to list. Yeah, that's how you use streams with an Ecto adapter that has implemented the right thing for you. And obviously, the other thing that may be interesting will, I think, for example, employee number 5, let's say. Do we have employee number 5? Repo. Yeah, we do have employee number 5. As you can see, it has a reports to association, reports and the manager. So you can do repo 1, then find the manager, and get it again, and then you now have the manager of that employee. And then you can do reports again, and then do repo all again, and then you will get all of the reports of the employee's manager, and so on and so on. So anyway, once you've implemented the inserts, you have implemented updates, and you have implemented deletes and executes for the queries, essentially Ecto will take care of the rest for you properly. Yeah, so I've got a few other scenarios which already run earlier, but I think I will just walk through them again. So it lists everything. Select with ID, select where, or select where, select a particular value only and do all, select something, and then update with change set, traverse the associations, or you can promote somebody to customer if you really want to, and that obviously works by update. Yeah, so you can basically do anything you want with Ecto against this kind of preset. And so it gives you really flexibility to, for example, reuse certain models that you have already created against your database, grab it, yank it, rebase it on top of an Ecto-backed preset solution, and get the benefit of eliminating one dependency without much changing of your application code. And in addition, obviously, if you got change sets and other validation logic based on Ecto already, you can reuse them this way. Right. So I think that's about all. Thank you.
Unfortunately, we don't have time for questions. So if you want to ask something, I'm sure you can find Evadne somewhere on the conference.
Yeah.
Thank you for the talk, and we'll resume the next session in 15 minutes.
Thank you very much.